Thanks again for joining us. Today's module is about adaptation resilience training with sort of specifics on infrastructure building resilient communities. So I'm going to drill into a little bit more detail and give you a few ideas and practice tools on how to do sort of climate resilience assessments and a variety of things. So really what we're trying to do here in this module is to demonstrate how climate change data is used in assessing risk and managing risk. We'll define climate parameters. I'll tell you what the definition of that means and also how to communicate impacts and quite a bit. Communication is a very important part of assessing risk. We have to understand each other and we have to be able to communicate how we want to move forward. This stream focuses on buildings, roads, and bridges. We've done that specifically based on just sort of some of the audience that we were trying to attract in this training, but this extends to other infrastructure as well. And you know, this infrastructure does include other categories of infrastructure. When we're talking about things, we also want to look at infrastructure we're assessing with a longer life cycle. And I think obviously we think of that when we design, manage, and operate our infrastructure. But I think in the context of climate change, it's very important for us to really look to the future to see how far into the future we need to look as well. So the breakdown of today's module will be just, first of all, talking about climate change resilience assessment. Some of the previous modules, the core modules, talked about some of the principles, and this is sort of the next level of detail as we move forward. I'll introduce the example project, and by example project, I want us to assume that we're sort of an assessment team, that we're going to get together and assess a very specific piece of infrastructure or pieces of infrastructure using this process. And risk assessment is very much a learn by doing process. So I thought that by showing a relation-based example, you'd be able to learn quite a bit more. And then based on that example project, we'll go through the steps of a PIEVC assessment. And I'll even define what PIEVC means a little bit more later. And that's defining the scope of the assessment, defining the type of climate data, piece of infrastructure or pieces of infrastructure using this process. And risk assessment is very much a learn by doing process. So I thought that by showing a relation-based example, you'd be able to learn quite a bit more. And then based on that example project, we'll go through the steps of a PIEVC assessment. And I'll even define what PIEVC means a little bit more later. Then we'll get into the risk assessment, which is the meat of the process, where we actually look at the consequence of various climate hazards, climate data on specific pieces of infrastructure. And we'll do that in a group exercise setting. There'll be 3 breakout rooms based on 3 different type categories of infrastructure, one being transportation, so a highway example, the second being a bridge, sort of a large bridge structure, and the third being a campground, which includes buildings and drainage infrastructure and a variety of things. And then we'll decide in terms of understanding, you know, that first process was the risk identification, and this will move into the evaluation of risk. What happens when we see high risks or medium risks of in future climate? And we'll have another breakout session, a little bit shorter this time, just to talk about actions that could happen. And really that will be the basis of the module, and we'll move into a question and answer session. So in terms of, Juliana pointed you to a slide, and this is sort of a similar slide, just in the context of other modules that were previously, I guess, delivered in the last weeks, and depends if you come through Climate West site and you're seeing this please go and check out those other presentations as well. And they'll give you some foundation to this infrastructure module in terms of understanding climate science to a greater degree, the language, definitions, the background. Talking about risk identification and risk management, which are some higher level principles of risk, some of the risk frameworks, and a variety of things that this infrastructure module, PIEVC, works within. And ultimately the economics, the dollars and cents of understanding climate risks, understanding climate action, climate inaction, and a variety of things. And just that importance of communication. Everyone has to be on the same page. We have to understand language collectively to move forward and to adapt to a changing climate. So some of these modules specifically, and although I wasn't, able to attend all these, I've seen many of these presentations in terms of PowerPoint, and they're definitely excellent. In terms of climate data, for an assessment, we really need to understand current and future climate hazards, climate data, in terms of making assumptions into the future. And a lot of these assumptions are based on predictive models that would be used and a variety of different scenarios that are established. So this module will speak to that and give you the background. I'll introduce some of those concepts into the training in the next slides. When we get into risk identification assessment, ultimately this module is part of that. But for the most part, we use some higher level ISO 31000 and other techniques to describe holistic sort of enterprise risk on infrastructure. So those frameworks are very important. Today's module will use these principles of understanding how risk overall affects the built environment, social, natural, and economic pieces. But we'll specifically be looking at climate risk, which is really what the emphasis of the PIEVC tool does as well. But it uses all of these principles of understanding hazards, events, conditions, and the likelihood. I mean, how often will that occur, or will that occur more in the future? What the consequence of that occurring, the impacts and consequences and effects. When we put those together and we assess those collectively, we define that as risk. And with understanding the risk and identifying risk, we have to understand how we apply risk in our day-to-day activities as a government official, as a utility owner, as an operator in terms of various infrastructure, a designer, and risk is a circular process of understanding that, monitoring, assessing, communicating, acting, and then reassessing. So it's this holistic wheel of applying things. The PIEVC tool will fit into this process as well, and we'll talk about that in a few slides. And ultimately, why does it matter? Well, the economics are very important. Understanding the effects of climate change and related costs helps us to prioritize our work, prioritize our actions. Ultimately, there's not enough resources to take action on all items. So having priorities, understanding high risks, medium risks, low risks, we'll understand how we move forward. But in the context of the overall economics, we have to understand the effects of different scenarios, different emissions as well. So it's very important. So the economics in terms of cost benefit and a variety of things come into play, and that comes into play very much in a risk assessment context. And following that, just discussion overall communication. In all the risk assessment work that I've done, communication is definitely one pillar of success in terms of things. Really, in terms of understanding risk, we need to understand it in terms of more than just what we see in the infrastructure in terms of designs and specifications. We need to understand how it's responded in the past, understanding sort of local knowledge and a variety of information, but as well as communicating back and forth between people who assess risk and people who need to take action in terms of risk. And ultimately, the full understanding that everyone's on this same journey together, with common definitions, common understanding is a very important thing to move forward to take action and risk. We have people with different levels of competency and understanding in climate science, climate adaptation, climate mitigation, and all of these things are very important. So communication is a very important aspect. But specifically for the rest of the next few hours, we're going to concentrate on climate resilience assessment. And we talk about infrastructure and climate, and I'm going to use those two components very much. Really the PIEVC process, which I'll introduce to you in a short amount of time, really is the junction of how does infrastructure respond to various climate. Now, we've been responding to climate in infrastructure forever. I mean, that's a reason that we build infrastructure in many cases, and those are the loads that we design to. But when we start to consider future climate and future climate in terms of design, it's really important to try to understand the life cycle, how long this infrastructure will be built for, and to what degrees, how far into the future do we have to look. It's not important, or it doesn't make sense to look too far in the future if your infrastructure will be repurposed or rebuilt in the future. So when we look at a variety of infrastructure from dams and water supply, we can have a variety of expected life cycles, 50 to 100 years, roads and bridges, 50, 100 years or so. And this also doesn't account, or there are other caveats in here of major rehabilitations and other things that extend the life cycle. But more than these specific numbers is the idea that we need to start to think in terms of the end of life, these areas, how our infrastructure will respond at the end of life, not just when we design it at the beginning of life, because the climate and those loads may be different at the back end. So why do we complete a climate change resilience assessment? Well, really the why is to deal with the uncertainties of future climate change. As good as the information and the science we have, there's a lot of uncertainty in what we have. And there's a lot of different paths that we can look at in terms of scenarios, in terms of how those climate models and other things are built. We need to deal with risk to physical infrastructure and infrastructure service. We need to have a defined level of service. We need to know whether that road will be open, that bridge will be open 24 hours. If there's a closure based on some climate event, how long can that be? How short can that be? If there's a hospital at the other side of the bridge, obviously we can't have any service interruptions. We need to, the core of our infrastructure and design as an engineer is the protection of people, property, environment. And understanding, these assessments helps you to understand that path. There's legal and financial implications. Ultimately, we don't want people to have anything happen in terms of the infrastructure, or that causes any damage. We spoke to life cycle and management of the operations, and that whole idea of reassessing and assessing risk, taking action, and then reassessing. And overall, to improve planning and to improve resilience. I mean, resilience is a term that's been kind of introduced into our lives a little bit more in recent years as we think about how we prepare and adapt for climate change. To be more robust. Maybe we used robust in the past, but resilience is a very good word. And ultimately, when do we do this? Well, climate resilience assessment, as I spoke to earlier, really should be done at the full life cycle. So really, we should be understanding and doing risk assessment at the planning stage, maybe at a very high level screening type assessment, where we look at exposure to climate elements and a variety of things. At the design stage, where we can do more detailed, comprehensive risk assessment, to the operation, where we are monitoring, collecting information, as well as assessing risk. And then as we upgrade, and then going through that cycle once again, moving forward. So a big piece of today is talking to you about the PIEVC protocol. Now, the PIEVC protocol is a risk assessment process. It's a technique, one of several, but one that works very well in infrastructure. And it's a systematic approach to assessing historic climate and project the nature, consequence, and likelihood of future climate change and events on infrastructure to inform infrastructure planning, design, operation, and management. PIEVC was originally I guess, the history of PIEVC. It was developed by Engineers Canada as an approach to assess climate based on climate risk for engineers. It's expanded. It's not just an engineering tool. It is a tool that can be used very usefully by engineers, but it is best applied with many stakeholders in terms of technical engineering, operation, planning, and administration. Excuse me. PIEVC, if anyone's interested, was really the name of the committee that Engineers Canada struck to build this process and tool, and there was the Public Infrastructure Engineering Vulnerability Committee, and we just call that PIEVC. Since its inception, about 15 or more years ago, more recently, PIEVC is now controlled through the ownership of the Catastrophic Loss Reduction Institute, the Climate Risk Institute, and GIZ, which is a German international, which looks after PIEVC on a international basis. To use PIEVC, you should go to pievc.ca and look at the terms in terms of applying that and getting the tool specifically. There's no cost, but there might be some registration and a few other finalities. And if we look at the graphic on the right, when I spoke to you earlier, I said today we'll be talking about infrastructure and climate. It's really this Venn diagram of the interaction of specific areas of climate that touched our infrastructure, like the wind on the side, the structure of a building, like temperature on roadways, temperature on bridge infrastructure in terms of expansion. And all of those areas will have specific interactions where there's something that can happen, and to the degree which those happen. And where things start to happen in a very poor way, or in a way that we're very interested in, we'll call that a threshold or a trigger in terms of things. So a lot of the risk assessment will be how these two things, our infrastructure and climate, how they interact. And in terms of the overall context of ISO and risk, PIEVC is just one type of a ISO compliant process. It's a multi-step process where we define infrastructure, which is the infrastructure that will assess a bridge, a roadway system, a building, a hospital, a dam, a network of a power grid, or a variety of things, or a portfolio of assets. We gather information about those assets. We gather information about climate and hazards that may affect those assets. We assess the risk on those assets, and then we evaluate that risk and come up with some action or conclusions. So that's really the simple side of the process. And PIEVC is ISO 31000 compliant, and often can be used and has been used very successfully in things like Infrastructure Canada's Climate Lens, or other Infrastructure Canada funding programs that are now on the sort of the docket in terms of opportunities for communities. For this climate resilience assessment in this module, what I'll be doing is introducing a project. So, when we thought about how we would describe PIEVC, this process, and some of the background in terms of how we've done this for other groups and other training, probably the easiest and best way to do this is to understand this through a particular project. So what we've done is we've selected an area of northern Alberta, around Rycroft, highway number 2. And what we've done is we've created a project for you as a team and me as an instructor to go through in terms of understanding the PIEVC process. So although this is specifics and details and actual photos about this isn't a true assessment. This is just sort of a demonstration assessment. So hopefully you can put your hands on something a little bit more tactile to understand. So highway number 2 between Rycroft and Fairview, and this will include the Vegan Provincial Park and a few other assets along the way. I look forward to you someday, hopefully driving through that area. From the pictures, it looks very beautiful. So now we're going to move to our first polling questions.
So I'm sure this question looks familiar to some of you because we asked it during the climate science session last Tuesday, but it's important to know sort of what climate impacts are the most relevant to your work for the PIEVC process.
So moving forward, I want to introduce the example project. So, what I'm going to do is talk about this region of Northern Alberta, talk about the project, and then I'll get more into introducing PIEVC, its steps and applications, and we'll do those side by side as we move forward in terms of understanding. So as I spoke to before, imagine at this point we're all sitting in a boardroom, hopefully not only a virtual boardroom, and we've decided, working with the Alberta government, that we're going to put a team together to assess a section of highway between Rycroft and Fairview and complete a resilience assessment. So very important in that is, first of all, how do we do that? How long does that take? Who should do that? And a variety of things. How much does it cost? All those kind of things. So, at this point, we've said we want to do this. We're going to put together a team. We're going to pick the PIEVC process, sort of more of a high-level screening process, to assess the major risks in terms of these infrastructure. Typically, when I put a team together to do a risk assessment, I need a variety of skill sets or subject matter experts involved. So I need persons who have knowledge in the infrastructure. So we need to have people that understand it, people that operate it, people that manage it, possibly people that have designed it. We need some people that understand how it's responded, that heartburn question of climate, just to keep track of things. Then we need somebody with some knowledge of climate science to put together some climate data related to our project and move that forward. We need potentially people that understand the risk process to go through this and do this in a validated manner, and then people to help sort of record it and communicate that to whomever. Is this to a government official? Is this to a funding program? Is this for whatever means? So this could be part of a climate lens assessment that's helping to achieve funding in terms of the program. So all of those things come into play in terms of things. But specifically, we'll talk about this project, Highway 2 between Rycroft and Fairview. The highway itself is a roadway. That stretch of highway is about 4.5 kilometers long. It includes spanning the river, the Dunvegan Bridge, as well as the Dunvegan Provincial Park. So what we'll do is we'll assess all of those in terms of detail. So if, going to our trusted internet, we can kind of see sort of a map of where Rycroft, the stretch of highway number 2, is to Fairview. It's a region north of Grand Prairie in northern Alberta. And I think if you look to the bottom graphic of the highway, that's a picture of the section of highway, very much a prairies landscape, fairly flat, some trees and a single lane highway. Sort of asphalt paved and, with typical shoulders and drainage infrastructure along the way. As it moves towards the Peace River, there's a major bridge structure to span that river. This is the Dunvegan Bridge. It's I guess that is a cable type bridge and a variety of aspects. You can see I'm not a bridge engineer, I just described that. And that bridge is very important. It's very crucial to span this area and for all of the transportation linkage between communities and other parts of the region. And that bridge, it looks like has a few years on it. It's been upgraded as well. And like any infrastructure, it will have had a history of how it's responded to the climate and how that will move forward. So, we have a section of highway, we have a major piece of infrastructure, this bridge. As well, just at that sort of the foot of the bridge on the north side of the Peace River, we have the Dunvegan Provincial Park. And within that provincial park, we have a campground and historic site. And we'll also take a look at and assess that site in terms of climate risk to see how things are. So within that, we've got a number of buildings, historic buildings, roadways, drainage infrastructure, and a variety of things as well. So our project today will be to assess these aspects using this risk assessment tool. So when we start this process and we define this process, we have to define the scope of an assessment. So, I've started to get into the details, but here's the actual process in terms of steps. So the first step in the PIEVC process, step one, is the project definition. So in defining a process, I've already spoken to you a little bit about the team and a few things, but really first principles is establishing what is your infrastructure. So in the context of this assessment, we have that highway number 2, the roadway, the bridge, and the campground site. What climate information is required or needed in terms of this assessment? And we'll get into that in a minute here in terms of what types of climate data, climate hazards, or other climate-based events are important to this infrastructure. What is the time horizon looking forward to that? I showed you some earlier slides about life cycle. So looking at these components, what are some of the life cycles that we need to look to? That's when we speak to a roadway, a bridge, and this campground, are we looking at that 30, 50, 80, 100-year timeframes? And in some cases, yes, but we'll go through that a little bit more. Importantly, what is the geographical setting? How are we setting? What is the climate zone? What is the topography? How does all of this relate in terms of the roadway? It's very long and linear, and we have to see whether climate information is consistent throughout. On a bridge, we have to understand that's a little bit more specific to a very specific zone, as well as the campground. And as well as we have to understand the applicable jurisdictional issues. Who owns this infrastructure? Who operates this infrastructure? Who uses this infrastructure? Is the public there? When we start talking about liability and usage and a variety of things, those are very important. So the starting point of an assessment is really very much a detailed understanding of defining the project with many of these parameters. And defining the project also is defining your project objective. Why are you assessing this? What are you assessing for what purpose? Are you assessing this for planning future infrastructure? Are you assessing this for a specific project that you're seeking funding for, like the climate lens, or other things? So that's very important. So that's the first part of the assessment step. So in terms of this example project, when we start to define the infrastructure, if we say we want to do assessment on a highway, we have to understand, what do we mean by a highway? And in very, very simple terms, in a very high level concept, we'll break the highway down into a number of components or number of elements, depending on what you want to do. So, and these can have subcomponents, and these lists can be very long. But for today's purposes, we're going to be very, very efficient in terms of just a few things that we'll look at. So when we're assessing, okay, there's a question here, I'll come back to that. The road, the pavement structure is very much important. So the road cross section, how the pavement depths, that's something we'll assess. That's a very specific piece. So when we think of a roadway and what we can see in the picture, obviously the asphalt, there's going to be some layers of base granular underneath that, maybe some geotextile drainage components as well. We'll assess the embankments in terms of that roadway. For drainage, we'll look at culverts and ditches. Drainage obviously is very important. When we look at, keeping this open, keeping the performance of this roadway as well. And we'll look at the safety in terms of that, the maintenance, the operation and maintenance. When we look at an asset, we also want to look at how it's maintained, because if it's not maintained, it will not react well to climate forces. So maintenance is very important. And we can look at things like guide rails and other safety components, signage in terms of things. So, if I look ahead, how is something like signage important to a climate assessment? Well, if we had a lot of, signage, we have fog, we have other issues, knowing and navigating is part of the importance and safety of that infrastructure. Excuse me. So we have a question here. Do you start with structural integrity analysis for existing structure? You may. So you might, depending on how you would and what the purpose of your assessment is, this might be part of an assessment project where you would have more knowledge of all of those facilities. In lieu of not having a lot of detail, you might bring in experts or subject matter experts who know that infrastructure, who can look into it. But to assess the infrastructure, you really do need to know how it's performed as well in the past. So in terms of that, I think that would make a better study. So, and we can probably speak to that in the example of a bridge. So as part of this large project, the second project is really understanding this Dunvegan Bridge, different type of asset, different type of piece of infrastructure, and definitely different elements that we would assess in terms of looking at climate risk assessment. And once again, these are some simple categories. We could have many subcategories below this and many components to assess. But for the purpose today, we just want to do a typical snapshot. So if we look at a bridge, we have the bridge structure and foundation, basically those, what's holding the bridge up and how that interacts with the ground and foundations and geotechnical considerations. The bridge superstructure, everything above those foundations that hold the bridge up, that bridge span. We have specific things like the bridge deck, specific joints and bearings, and the drainage infrastructure on a bridge, which is very important. Then we have some of the safety infrastructure on a bridge, which is also key, lighting, railings, and the maintenance that is done on the bridge to keep it open and keep that level of service. And then on the context of assessing a bridge, obviously the bridge is there for a purpose, is to scan either some type of infrastructure, but in most cases, or in many cases, a river. So the river is very much important in terms of the river flood-based aspects, elevation, in terms of the bridge. But also it could be some of the environmental considerations of the river itself, how this infrastructure is affecting that or could affect that, as well as the shoreline and other riparian type areas in terms of the bridge infrastructure. So that's a snapshot of how we might break down the bridge infrastructure and understand the bridge infrastructure itself. Excuse me. When we move to another category of infrastructure, the provincial park, we have other characteristics of infrastructure, other types of elements. So whereas the highway is very long and linear, the bridge is heavy civil structural, the provincial park is a little bit more related to buildings and structures and civil infrastructure. So when we look at the provincial park, we'll assess the park buildings, and the buildings will be wrapped up things like the building envelope, foundations, roofing, and a variety of things, the HVAC. Historic buildings, they may have a different characteristic or a different archetype that we want to move forward and have than other newer buildings. We'll assess the roadways and paths in this infrastructure, the drainage infrastructure, the power and communication infrastructure in and out of the site, which is very important, the maintenance, the shoreline again, in terms of how this area is affected. And then because this is more of a public site, the public use and safety as well of this. So in terms of the projects that we're going to put forward, when we talk about defining your infrastructure, we're looking all at each one of these three projects as how we've come up with a concept to define each piece. Now there is guidance in PIEVC of how to do this. There's some representative elements and things to move forward as well, but this is kind of an idea. And does anybody have any questions in the chat related to this? This is also will be used, these categories and elements will be used in the breakout sessions. So if there's a few questions, you can always ask those of the facilitators as well. So in that step one, we've defined the elements or the infrastructure we're looking at. Now we get into sort of the meat of a PIEVC assessment is its sort of emphasis on climate. And risk assessment is risk assessment. We can assess risk for a variety of regions. We can have a construction project and have a risk registry of all the things that can happen on a construction site. So we do understand risk in terms of our day-to-day lives and a lot of our work, but this process is a specific look based on climate. So when we start to think about climate, I'm using that as pretty much a whole category of understanding of hazards and climate information and events. Now, in a previous module, when we started to identify risks, we have to kind of understand what kind of typical things can affect infrastructure. So, as we move forward, there's a lot of good examples around things. So if you look in that left graphic, if we see something like bridges and structures, things that can affect a bridge are fire, drought, floods specifically as well. Roads, flooding is very important to roads in some context as well. So I think wind can be important on all aspects of it as well. So that's very important. So in the context of PIEVC, the first thing what we'll do is kind of ask the question, and just like the polling question, what kind of things were very important to you? But in the context of an assessment, will also be very important to have an initial sort of shopping list of some typical things that might affect various pieces of infrastructure and these categories. So things that I would say of interest to infrastructure are temperature-based. And these are loads or data that happens or things on infrastructure. So things like mean values, like average temperatures, average annual temperatures as well, and extreme temperatures, very, very hot, very cold, heat spells, extended periods, temperatures above, say, 30 degrees, 35 degrees that may affect your infrastructure. When we think of, a lot of our, built environment, we understand extremes quite well. Very, very cold temperatures, very hot. More in the natural environment is when we get into the means, the average temperatures changing year over year that it may affect species and invasive species and a variety of things. Then, one of the things that rated very high was rainfall intensity. So precipitation as rain is very important. And there's many categories of climate information related to types of rain. Once again, things of average annual amounts of rain, extreme rainfall events, wet periods, drought conditions, and overall the intensity and frequency of rain. It's important. If I'm a drainage designer, I use IDF curves, intensity, duration, frequency curves to size infrastructure. And the basis of that is climate-based, so we need to understand that for future-based climate design. Precipitation and snow is very important as well. We are in a northern climate. As much as it wasn't on the polling questions radar as the peak one, I think if we asked several questions down the line, this would be important. So snowfall amounts, average snowfall amounts, or snowfall deficits, it can have a variety of effects. Rain on snow, snow loading on buildings can be very important. And the type of snow on roofs is changing. If it becomes wetter and heavier, that can cause the failures. Things like hail in terms of things, ice accretion, ice storm events, ice buildup events that are becoming more important. You probably have knowledge, if many of you are in Alberta, but there was, we looked at that about 15 years ago in Quebec, Ontario, ice storms being devastating. In the Manitoba context, about 3 years ago, we had a fall freezing rain event that just destroyed power infrastructure, urban canopies, and a variety of things. So ice can be very important. Flooding, river flooding, a variety of flooding events, high intensity localized flooding events are of importance. Fog for visibility. In terms of that's important for transportation infrastructure. It could be very important for the bridge infrastructure. Frost in terms of freeze-thaw cycles, changes in frost season are important things. as well as wind, extreme gusts, thunderstorms, tornado, and a variety of categories of wind. And you know, obviously in northern Alberta, and not just in northern Alberta, across many regions of our country, fire is becoming an even more of a challenge in terms of fire itself, as well as smoke and other aspects related to fire. And then things like lightning and a suite of other things that can happen. So when we start thinking about your project or a project in terms of what's important, you know, we have to start to think of these kind of events. And we'll categorize that as climate parameters. So in terms of our project that we're taking on, and this might be a little bit hard for you to read, but what I've done is taken this list of potential items and highlighted those that I think are relevant to this roadway, bridge, and provincial park infrastructure. And those will include aspects of climate means and climate or temperature, excuse me, and means and extremes, precipitation. Precipitation is snow, ice, flooding, fog, ice in terms of the river, frost for freeze-thaw cycles, wind, fire, and lightning. So those are all aspects that I would say I would give this shopping list now to my climate scientists to come up with some general ideas on what is the climate profile of all of this infrastructure. So that's sort of the shopping list, that my climate elements that I'm interested in. But the second part of climate is, okay, now I want to understand how far into the future do I want to look and get information on. So if you were, you know, fortunate to be part of that climate module, they would have talked to you a little bit about future climate scenarios and a variety of things. So I won't touch on that to a great degree here, but I'll touch on it a little bit. So when we look at future climate and these infrastructure life cycles, we want to look how far into the future we want to complete this assessment. And based on a lot of the climate models, there's a lot of typical time frames or data sets that are being used. So the current climate, or climate scientists might call the, you know, sort of present or the recent past, based on sort of a data set that's already happened, is sort of the climate information that we see today. So if you go to Environment Canada and pull up information, you'll see sort of the current or recent past. If you say Googled a community and they would show you sort of typical climate information, it would kind of give you what average temperature is, what high temperature have been, and all those things. More of the stuff you might see on the Weather Channel and stuff as well. Moving forward, though, when we look into the future, it's not climate data anymore, it's climate projections. So we have to, now it's some estimate of what that future will be. But the first piece of that infrastructure is understanding that time frame. So very much for the purposes of a lot of the climate models and a lot of durations, there's sort of a lot of common data sets around years, what we'll call the near future, you know, sort of that look ahead to around 2050 in terms of climate, and then out farther, a little bit farther into the future, the 2080 timeframes. So for our life cycle and looking forward, if we look at sort of like a 2050, 2080 design highlight or design horizon, that'll be important for this assessment. You can also find very specific data on a particular year. If you have a good relationship with a climate scientist, you can look to 2100 or beyond as well. But I think for the purposes of doing assessments, some reasonable near-term and far-term horizons are usually used. So in the case of our assessment, we'll assess 3 time periods in terms of these structures: the recent past, which is our current data, 2050 data, and 2080 data. So that's sort of defining in your assessment the timeframes. So then we have to understand, so we know the timeframes, we know we've decided sort of what is the shopping list of climate information, we've decided how the bridge is. Now we have to understand some of the contextual geographical settings and jurisdictional settings as well. So, you know, this infrastructure is owned by the government of Alberta infrastructure, the roadway, the bridge, and the provincial park. Maybe the provincial park is a different department, but ultimately it's government infrastructure and it's maintained by them. So the operation, maintenance, actions of risk will be through the government. So that's important in the context of the second part of this exercise today will be, what do we do when we identify the risks? And within the context of that geographical setting and jurisdictional setting is, what are the abilities of that asset owner to take action, and as well as what knowledge they have in terms of information on that. So that's important in terms of just understanding the context of your assessment. So when we get into defining climate data, this is really I would say the more important or details related to the PIEVC assessment. And I've been speaking to you about that as well. So in terms of past slides, we've gone through a lot of that, kind of summarize it. So well, we need to put some climate baseline, and that's what we talked about, that recent past. The climate change side is us using those 2050, 2080 projections that we saw in the time horizons. So really, we've defined ourselves in terms of looking at this 2050, 2080 highline. When we also need to talk about the level of precision of the assessment and the level of detail. And this will come into the next slides. So I'm assuming that for this assessment in this project, and our objective is to do a fairly high level screening, not a very, very deep dive into all the climate aspects. And you'll see why in a little bit. And the difference between very detailed information in terms of climate and the level of detail and what we'll do today is the availability of climate information. So, and I'm not sure if you had the opportunities to see that previous module, but I'll give you a little bit of background, what I'm anticipating they covered as well. So when we need to do climate assessments, we need to find our climate resources. So that shopping list of climate, all those temperature, precipitation, fog, freeze-thaw information, we need to find real-world data that we can assess, data and projections. Now, we're very fortunate that across Canada, we have many, many good resources to find this data. When I first started assessing PIEVC in about 15 years ago, there were only several high-level institutes that could prepare climate data for a good assessment. Now, moving forward in the last years, we have great resources that do and provide information for you within minutes. And I will actually show you an example of that in a minute. Examples are climatedata.ca, a new Government of Canada type site that provides climate information. Climate Atlas of Canada, which is a very, very good source at climateatlas.ca. And I'm actually going to go to that website and show you how to get information. And a variety of park data applications and a variety of portals in terms of things. There are, things like the Pacific Climate Institute, Uranus, and other institutes across Canada that provide information as well. So the resources in terms of climate information is that. But that's not all the information we'll ever get in terms of climate. We'll also have to understand the natural environment around us. So if we're assessing something like the campground or the bridge, we can't go to Climate Atlas of Canada and get flood mapping. We'll have to do that in other sources, provincial sources and others. We'll have to look at previous studies and potentially need to do some modeling. So the precision of this assessment will be based to a degree on available information, needed information as well. So we'll navigate that. At a screening level assessment, we may not need as much very specific data, and what we'll use sort of a proxy data or approximated data to do the analysis. And really refined data sets and technical documents prepared by municipalities that can be leveraged. So, if you're a community near the city of Edmonton, Edmonton has already prepared a lot of climate information. And if you're close enough, you could potentially relate to that. This project's too far to do that. but that's there. So excuse me, I'm just going to take water. So very specifically, for this project, when I look to this area of highway number 2, and I go to some of these climate portals, I've selected a very specific region, something very close by, and in this case, Spirit River, as a proxy of a location to gain climate information. So I would go to the Climate Atlas of Canada, and putting Spirit River and looking at different scenarios, it would provide a bunch of data for me in terms of precipitation, temperature, temperature extremes, as well as some frost information. And it gives them to me in two types of emission scenarios. One, an RCP 8.5, which is a very extreme or a more extreme view of future climate with a high carbon future, sort of a worst case analysis, and a lower carbon, an RCP 4.5, which is also there. And I'll explain some of these terminologies and a few things later. So that's very important. So when we have that shopping list of climate information, we can get some of it from these climate portal sites, and in the case of Climate Atlas of Canada. And here is some very specific information for RCP 0.5. So if we look at how to understand this information, we see something like the current period, which we'll call 1976 to 2005. And that's been recently updated. But this is sort of what we would consider our current time frame. So if we have an annual mean temperature of 1.9, in 2050, we're looking at that temperature being about 3.9 degrees Celsius. And in 2080, or at the end of 2080, we see it to be 6 degrees. So we see a rapid increase in terms of average temperatures in the region based on this emission scenario of 8.5. And that information that gets plugged into our assessment. So I did click on from the Climate Atlas of Canada, we have the map. We navigate through the map of Canada. We go to the community of, where are we? Hold on here, north of Grand Prairie. We come down and we see Spirit River. Okay. And once again, so just talking you through, Spirit River has a variety of climate elements. And you can still see this, Sarah?
Yes.
Okay.
Yeah,
so
you're clicking longest spell of plus 30 days. Yeah.
So we can have a variety of different things in terms of different climate parameters, longest spell 30 degrees. So in the current climate would be, less than a day on average in a year. So once a year, whereas we're looking at probably 2 to 3 days into the future in the 2050, and maybe up to almost 6 days in terms of the future. So we're looking at more hot weather and longer durations of hot weather in the future. If we look at things like precipitation and heavy precipitation days, and we rated that as one of the most important things for there, we're looking at things like in this 2050 range of, something like a heavy precipitation days where we get 20 millimeters of rain or greater, being about around 1 day, into the future around 2 days, and into the future just over 2 days. So we're seeing, although there's increases in heavy precipitation, it's not that much more than the norms in terms of this Spirit River region. And Spirit River is very much within this region that we're going to be calling where we're doing our assessment. So this information is there. If we drill down to the climate, we can download these overall reports, and that brings us back to the slides that I was showing. So in terms of climate information, these sites can give you quite a bit of information along a variety of climate parameters in terms of things, cold weather, freeze-thaw cycles, a variety of things that are very important to infrastructure. So hopefully this information, so if we go this previous slide and assess the climate, we can start to see that information comes from the Climate Atlas of Canada to give us all the details. The specifics with different emission scenarios moving forward. So what do we do with that? How do we use this information now? So we have that shopping list of information. So we have to somehow, through this risk assessment process, turn climate information into sort of a likelihood number. And the reason we do that is because when we assess risk, we have to, first of all, assess how often this may happen, or how often it may happen a little bit more in the future. And one of the tools that we use here is turning various climate information into some type of a likelihood score. And in the case of PIEVC, we use a 0 to 5 scale in terms of assessing that. So we have to, and this would be done by the judgment based on our subject matter experts and our climate scientists to establish these. In the case of our assessment, I'll show you how I've done this. So if we have sort of our present, and we're talking about this mean temperature, annual mean temperature. So if we have a current temperature of about 1.9, we're calling that to happen basically in a very likely thing. So it's a score of 3. As we see that temperature increasing, we increase the likelihood as well. So we have different scores. So it's very important that we go through that process, and that's usually done by this expert. What we'll do is we'll then take and do that exercise for all of these climate parameters that we've assigned. And this will be something you'll see in the workshop. So things like for an annual temperature, we've assigned numbers. For extreme weather amounts, we've assigned certain numbers based on the specific climate data as well. And something like freeze-thaw cycles as well, we've looked at that. And in some cases, although counterintuitive, some of these things are being reduced. Like freeze-thaw cycles, even though we're moving into sort of warmer winters and a variety of things, we're seeing the trend towards the projections telling us that there'll be reduced amounts of freeze-thaw cycles in the future. In this case, for this region of about 86.5 currently in terms of things, to a reduced amount of 67. Now that's important, but it's not that like freeze-thaw cycles are going away, and that's very important as well. So now that we've given you a little bit more background, we've sort of laid the stage on what we're going to assess in terms of the infrastructure. We've have a little bit of a shopping list and developed climate information developed into the sources that we want. We're going to assess the risk, and really this is moving into the next phases of PIEVC and the risk assessment. And really this is the core of the process in terms of things. So and when we're assessing risk, it's first of all important to understand a few concepts. So risk tolerance is very important. So for us to ultimately define risk in terms of medium risks, high risks, or low risks, we have to understand what level of risk that infrastructure owner or operator is willing to take. And that's a conversation that we will have throughout these assessments in terms of understanding risk. PIEVC has suggested a number of thresholds for high, medium, and low risk, but those can be adjusted based on the risk tolerance, or some would say risk appetite, of the assessor and the owner. Ultimately, if you have an area that is prone to flooding, an example would be if you have a very, very high level of risk tolerance, you can say, let it flood, I'll clean it up later. That's acceptable to me. If you have a low tolerance of risk, you might say, let's protect that, let's do something different. So those things are important in the context of any risk assessment or any process. And those are probably conversations that are newer to many organizations in terms of climate. Some other important considerations are these climate interactions possible? Can this event happen on that piece of infrastructure? Well, we usually look to the past to give us some indication. So has this campground or this park area flooded before? So is that possible? But we can't just limit ourselves to what has happened in the past, because there are new events and new things that can happen that haven't happened before. And we see that in a variety of things around us in the media when we pay attention to climate. But it's very important. So it's really, that's that whole exposure or interaction conversation and analysis that we do. Also important when we assess risk is not, it usually doesn't just rain. It usually doesn't just freeze. It usually doesn't, the wind doesn't just blow. They all tend to happen at the same time. But for the simplicity of, and probably the practicality of doing these risk assessments, we tend to group those individually, because the climate information and projections around those. But we really have to build models of cumulative climate events, combinations of events, and effects on infrastructure, as well as effects on downstream infrastructure, not just what we're assessing. So those are very important, and just that whole idea of cumulative effects. It's, when we're assessing risk, important considerations on likelihood scoring. I touched on it a little bit, where we turn that climate information into a likelihood score, 0 to 5. There's a lot of process and a lot of work that can happen behind that to get that, in terms of truly indicating that likelihood that we're assessing the risk based on. And something like the PIEVC protocol, the documentation guides you through a lot of that information, how to do that. There's a lot of, I would say, the state of knowledge in terms of climate science that will help you with that. And there's a lot of practitioners in terms of who have done that in the past related to that. So PIEVC.ca and the tools that you can find from there, the PIEVC protocol, and in a few weeks, looking forward, the new high-level screening guide that will come out will provide more guidance on those types of things. In terms of assessing risk, the consequence scoring, once again, those scales are very important. Really, how bad, like if this event happens, how bad, and what is the consequence, or what is the severity of that? All of the language around that is very important for assessing risk understanding. But to understand that consequence, you need to have assessors that understand the infrastructure, understand how it's reacted and how it may react as well. And really, judgments and uncertainties. We had the question about the uncertainties in the climate science. Well, there's a lot of uncertainty, and there's a lot of professional judgment that's required in these assessments. So that's important. I think it is important that we do make these judgments, that we do document our assumptions, that we do move those forward, and not just not act because we don't have all the information in front of us. And really, this is a screening process of establishing higher risks. And with those higher risks, what actions would you take? So it's really important to move through this. So this next step, or this risk assessment step, it's important in a lot of ways to understand the framework of assessing risk, some of its limitations, and a lot of the positives. And I think it's a very important tool. So really, when we look at risk, and this is the fundamental of how PIEVC defined risk, risk is the product of the likelihood of an event, how often does it occur, more or less, and the consequence of it if it should occur. And this is really what our next steps in this risk assessment process are. So the consequence of, if we have something like an event that has, we'll take a flood or something like that. If we have a flood event that has a very low consequence, it's just a minor flood. It happens, once in 100 years. That's a low consequence, and a low likelihood event tends to be a low risk item, something we're not too worried about as well. As the consequence increases and potentially the likelihood increases, we move into areas where we have greater risk scores, and therefore medium risks, and even more so in higher risks. So a very high consequence event in a low likelihood can still be a low risk, but as we move into the future, that can change. And really, when we look at the influences of climate change, we're starting to see increased likelihood of events. So that same event that happened less frequently and therefore had lower risk is happening more often, so the risk is increasing. And really, this is the whole idea of what we're looking at in terms of an assessment. In terms of risk tolerance, risk appetite, where you see this graphic on the right, you see the grade sort of areas where we have zeros and up to 9s in terms of those numbers in the table. That's a low risk items. Those are areas where we see medium risks, or yellow, scores where we, risk scores where we have higher likelihood and higher consequence in the 10s and 15s and 16s, that's medium risk. And where we have very high risk, or high risk, of 20s and 25s, the red areas. That's the product of this assessment, is some idea of categorizing low, medium, and high risk. And then based on those identification of those risks, deciding what I do with that knowledge moving forward. And we'll see that this risk profile of the infrastructure that we're assessing will change in time. So the current risk profile versus the 2050 or 2080 profiles will change as well. So in each place, we need to understand how that moves forward. In terms of risk tolerance, you could adjust these scales in terms of maybe some lower risks are more important or high risks are more important. And I think as you use this tool or these processes and you become more sophisticated, you can have more judgment. But for the most part, these scales kind of work for most assessments. But it is very important to understand that risk is really a product, and very simply in terms of the PIEVC, and there's other definitions of risk and other definitions for different tools of the likelihood of an event and the consequence of the event. We could put in there, some influences on exposure, on how much exposure and a variety of things, but for simple purposes, risk is the product of the likelihood and the consequence. Now, moving forward, so that, in this assessment of how we assess now in terms of using PIEVC and moving forward, what we would do is the risk assessment or risk assessment process now is a process of establishing likelihood and consequence scores. And based on those scores, having a resulting risk final score so that we can, establish low, medium, and high risk. And this is where we're going to move shortly into the risk assessment worksheet or the group exercise. And we're going to move you in and we're going to do the actual work. But I wanted to first of all talk about the tools that PIEVC tends to use for this. So we tend to use as a risk assessment worksheet, which is a summary sheet that takes all of the infrastructure components. And if you recall, when we defined a highway, we talked about the road, the pavement structure, embankments, drainage infrastructure, culverts and ditches, and highway safety and such. Bridges, we have the other components, and for the campground as well. So we've developed a worksheet that you'll move into, and you'll work through all these components one by one, these elements in terms of assessing. So this is the model in terms of defining the infrastructure or the components. At the same time in the worksheet, we have all the climate parameters that we've developed, what we've selected for this process in terms of categories of temperature. So annual temperature, summer mean temperatures, winter mean temperatures, and some of the extreme temperatures, say days above 30 degrees Celsius for an extreme, days below 30 degrees Celsius, freeze-thaw cycles and such. Now these particular climate elements may not be the perfect ones, but these are the ones that we say are, through Climate Atlas and others that are more available, and we'll call that a proxy. So although a true threshold may be 32.3 degrees based on some pavement structure design calculation, but we'll use 30 degrees as the represents an extreme event in terms of hot. So all of these are provided for you, and we'll go through those in the worksheet. They have as a definition what those are in the units, and just information related to the particular data, and then the projections related to that for the present 2050, 2080 timeframes, and the likelihood scores that are approached. So if you were part of an assessment team and you were invited to a risk assessment workshop to work with stakeholders to develop this and put this forward, which is the most valuable and technique of doing this is to do this in an assessment group, you would see some type of variation of this kind of sheet where you would go through this process. So really the assignment of likelihood scores would be done by your climate team, your climate specialists, and really this worksheet and this workshop, or this risk assessment workshop, which we'll do the breakout session, is purely a conversation of consequence. If this happens, if a 1.9 degree temperature annual day happens on a pavement structure, what is the consequence? And I would say that's probably fairly minor. So we're going to go through this exercise starting in a minute here of really having a conversation about consequence and really filling out this table in terms of things. Now, in terms of this workshop in terms of this training, this process is usually done over many hours, potentially with an assessment team doing initial assessments and a variety of things. For the group breakout session, what we want to do is we'll start to do a little bit of this work so you can kind of see the scale, the flow, the conversations that happen around that. So that's it. So when we started this whole process, we talked about infrastructure being one wheel and climate parameters being the other, and where that interaction occurs. This worksheet is really where we understand the consequence of those interactions. Okay, so this is a process, and this is a tool that's used in most PIEVC assessments. You don't have to do a work assessment worksheet if you're doing a large portfolio of work, many elements, many climate parameters, many zones. You might need to use a database or other format to do this, but I would say 99 out of 100 assessments, this would be very valuable for. So now, Sarah, I'll maybe pass it back to you and explain the exercise, or do you want me to explain it a little bit and then move it forward? Well, we can kind of collaborate.
Yeah, so maybe I'll just outline how we're going to do this from a logistics perspective. So what we're going to do is I've created 3 breakout rooms, and I have made them such that you can join whichever breakout room you feel like you have more knowledge or interest in. So the 3 breakout rooms are going to be facilities, bridges, and roads for the sample project that Jeff has been describing this morning. So what we're going to do is I'm going to be in one room, Jeff is going to be in another room, and Juliana is going to be in the 3rd room. And along with us, we are going to have a subject matter expert. So as Jeff's been talking about, this is a very collaborative thing. So Jeff, Juliana, and myself will more so lead the PIEVC process with the help of an expert in each one of our rooms. So, and each of us will walk you through the spreadsheet that Jeff was just describing. So if you have any issues with the breakout rooms, let me know. I will try to help, but I will also be trying to facilitate one of the breakout rooms as well. So I'm going to open all rooms in a minute. Please choose whichever room you are either more interested in or you have a strong background in. Obviously, we'd love your input. If you're an expert in roads, we'd love you in the roads section. Juliana, Jeff, anything you'd like to add before I open up these rooms?
No, I think in each room we can kind of ground what we're trying to accomplish and answer a few questions. But I think really the objective is to work as a group, which is pretty typical. And you know, we're not gifted with hours to do this. This is just sort of for you to get a representative feel. So maybe about 20-25 minutes worth of collaboration, and you can. Sarah, you can bring us back in a certain amount of time. I think we're pretty close to our desired timeframes, so you know I think we're okay. And this, hopefully, you get something out of that. So I will first of all, you know, thanks everyone for participating. I was facilitating the roads group. We had a smaller group. We did have the ability to go off mic and have a little bit of a conversation, so that worked okay. Thanks. There was some good feedback. You know, I was sort of the lead assessor, but I had good feedback from the team as well. And so a couple of the observations that we had on the transportation side, obviously we filled in some of the details. I think we understood that some of the categories of our road, how we put our road infrastructure is, there were room to add categories. There was room to add categories in terms of the roadway for sort of green infrastructure. There was, you know, understanding how some of the flood risks may or may not affect this area for flood jams and a few things. We understood that we would probably need a better team in terms of having people that had knowledge of the operation and the technical side of this. And that, you know, also that some of the infrastructure, the time frame of some of the infrastructure had, even though we were looking at 2050, 2080, say something like a pavement may actually have a shorter lifespan and may be replaced multiple times within that. So the adaptive capacity within that. So all those conversations came into play in terms of understanding that risk profile. I think we were successful to go through a couple of categories and at least hopefully show that process. So that was sort of the roadworks. How did, Sarah, you were in bridges. I'm
The
very intrigued.
bridges. Yes. So overall it went well. I think one of the important things that we discussed in our session was that we're looking at, when we rate the consequence, we are looking at right now, is this a concern for this piece of infrastructure?
Yes.
And right now, what will be the consequence? Because the PIEVC spreadsheet sort of predicts forward. But one thing we also talked about was, you know, what do these consequence scores mean? And you know, coming up with definitions of those with the group that you you have with you.
Yeah, and I think when we look at those scales of consequence, first of all, different assessments can use different scales. The original PIEVC protocol is a 7-point scale with different terminology in there, and we're tending to move to a 5-point scale because Climate Lens and other ISO frameworks use that. But within those definitions of consequence, that the one that I provided for this workshop is very subjective, you know, in terms of things. You can have other scales that are more quantifiable in terms of return intervals of likelihood, you know, 1 in 100, 1 in 10, 1 in 50. We could have some that are very economically slanted in terms of potential consequence in a cost value, like no zero amount up to a lot cost, or a variety of others. And some assessors may already have done risk assessment work with other scales. So you could apply different ones. This subjective based one tends to work in larger groups, but it can be tweaked. So it is something. So hopefully that's some of the questions that you're going after.
So Jeff, just to follow up on that subjective thinking, in my group on the facility side, Denver and Kevin were asking about, is there a risk of overestimating or underestimating your consequence? And maybe you can provide a little bit of guidance on that. Yeah,
well, I suppose, I mean, ultimately what you're trying to, at the end of the day, create a risk profile that's low, medium, or high. And I think low risks will take care of themselves largely. You know, it's something that you still pay attention to, but it's in the back of your mind, but you probably don't take action on. And high risks are probably overestimating means let's take some action. High risk, we should do something about. It's really the essence of what we're really trying to understand in terms of prioritizing risk and prioritizing activities is, how do the medium risks come into play? Are they closer to high risk or closer to low risk? So the first part of risk identification is coming up with that number, but also looking at it in terms of what we believe. So each one of those risk scores has hopefully some background of why you selected that, maybe some range of opinions of why you selected that from your assessment team. But also as you move forward, your risk actions move away from a risk score into actual world data and analysis and true threshold analysis and true design. So I think whether you've overestimated or underestimated, I think you still need to take next steps to prove your action in some ways. And that's what the second exercise would be. Okay, now that we have a little bit of an understanding of the risk, what do we do with risk? So, you know, it's very, I'd say it's easier to identify risk and prioritize risk. What to do with risk is a more challenging discussion.
That's a good segue to the next session. But before we go to the next session, there's another question, whether or not there's a sweet spot of number of stakeholders to engage. Is, you know, just avoiding too many voices may disagree or having arguments. Well,
I think first of all, each assessment team will be different. I think understanding that there are some dynamics is important related to assessing. What we've seen, you know, a tabletop assessment can be a handful, 3 to 5 people. And we've seen large group assessments of, 50, 60, 80 of tables of eights and stuff where we've looked at large assessments with multi-stakeholders and try to categorize people in different areas. I think as you look at engagement in stakeholders, you have to build the program to understand how you would shape that and how the results would be there. But I think it's definitely important to understand the value of that as well. And it could be that you have different, you're assessing different considerations of risk. You might be assessing more of the technical side of risk, so you can potentially group technical people together and have a certain risk profile. You could assess the level of service in terms of maybe emergency response, a variety of things, and have a different level. You could have the management and operations side, which can be a different level of risk. So, within this, you have different layers. In a very simplistic risk assessment or high-level screening, you can kind of merge all those with a variety of stakeholders and things. But I think you need to manage your boundary conditions, and you need to manage your resources in terms of this assessment as well. But each one of those things is very important. So hopefully I've answered some of that question. So in that group exercise, we took care of that sort of intermediate step of a risk assessment. And risk assessment is a risk identification piece. So if we would have gone through a more detailed time frame and exercise, we would have completed all those worksheets. We would have sort of an understanding of all of the slice of risks from each one of those parameters for each climate event that was relevant. And we would have some idea of those risk profiles. And then we would start to move into the next section of evaluating the risks and moving towards treatment of risk, because obviously just identifying risks is important, but what do we do about it? I think that's the next stage here. So in terms of the PIEVC process, there's two kind of steps that we would go into for risk evaluation and then risk treatment. In the conventional aspect of PIEVC, once we've established these risks, especially related to these medium risks, we would start to probably have another layer of engineering analysis. We would look at sort of that actual piece of infrastructure. We would look at that very specific climate data, and we would drill into sort of the thresholds of that particular piece of infrastructure. Say it was a flood. So if we said, okay, there's a risk for flood in that piece of infrastructure, we would go in and determine what that flood elevation was, what the likelihood of that event was, and to see if it's actually a risk or not a risk, or to see how that perception is. So that area of an engineering analysis is very important, but it's also time consuming. It has degrees of certainty and uncertainty, and it has a high resource need, meaning cost. So many assessments, high level assessments, if you're looking at something like a climate lens assessment, a lot of, hello? Oh, sorry, somebody needs to go on mute. So if you're looking at something like a climate lens assessment, usually something like engineering analysis is omitted. If you're at a pre-design stage, what I would say is you would do sort of the risk assessment, and then you would push this into a design next step. So engineering analysis isn't there. So in a lot of cases in a high level screening assessment, you might omit step 4, which is engineering analysis, and go straight to some next steps or conclusions. So that's important. So in terms of when we've done that risk assessment, we would then go in and prioritize those risks, sort of group them into low risk, medium, and high risks. In most cases, like I said, we're interested in medium and high risks. Climate lens, once again, Infrastructure Canada's guidance is to comment on medium and high risks. And what we need to do is also review, in those conversations in the workshop, the rationale for each one of those consequence scores. So we had somebody say, okay, I think that's a 4. And then they gave a story of why, maybe on a previous understanding of how a past event happened, or based on some future work as well. So those are very important. And really based on those conversations, this prioritization of risk, we're starting to develop an idea of what to do with risk. We need to understand it in the context of how it fits into that organization, into the maintenance processes, into capital planning, into a variety of things on how we move that forward. And really the risk treatment gets to move back into the processes of that organization and those ideas. So when we start to move into next steps of understanding, we've identified these risks in terms of these high, medium, and low risks, we need to take some next step. And really, when we take any risk action related to climate change, probably in some cases, we put it into two bundles, some idea of risk mitigation or risk adaptation. Now, we probably, many years ago would have used these same terminologies between two things. We probably would have capitalized both. I apologize on that slide. But we've kind of in the sphere of climate science, climate change, we reserve the discussion of mitigation is to more of actions that reduce future climate and carbon and activities, and adaptation is the reaction to climate in terms of our actions. So really in terms of a risk assessment and adaptation, or risk assessment and treatment, excuse me, we're talking about climate adaptation. Within adaptation, we may take mitigative effects. We might do sustainable practices. We might look at lower carbon solutions. We may look, and we should look at green infrastructure solutions as our treatments. But all of those, in the most part for a PIEVC assessment, are framed within adaptation. So that's really what we're looking at, where we've identified those risks in the risk assessment. What should we do? And really PIEVC gives some simple categories of what and how to frame that. So in some cases, if we have low risks or medium risks and we're comfortable with those risks, we say there's no further action. We're okay. The infrastructure, it looks like it'll respond well. Maybe if we're looking to upgrade it in the future, it will take care of those future things. We're okay. Or we need to take some other action, some remedial action. That's where we need to armor it, protect it. We need to somehow understand it differently. And that's where, in some cases we can say avoid it, move it, accommodate, retreat, some kind of action. So if it's related to a flood, we could build flood protection. We could go upstream and try to have flood mitigation in terms of reducing peaks of floods. We could build infrastructure that's higher or more resilient to influences short-term floods, moving equipment up to higher elevations, making structures that are able to take minor floods, or a variety of things. Those are remedial actions. Those are actions or adaptive actions. Or we could take management actions. We could, in some cases related to some of these things, and when we are assessing the highway piece, there could just be changes to the standard operating procedures. We need to clear snow more often. We need to, cut grass on embankments at a greater interval. We need to go and respond to high intensity rainfall events, make sure that culverts are not plugged at a greater interval. We need to put some protections in front of those culverts because of debris flows or other things that we need to worry about. So those are potentially actions, and they might cross a few categories as well. Or in some cases, other actions, we don't know enough. We don't know enough about this flood event. We need to go get more information. We don't know enough about a strong wind or a ice event that we can make any conclusive values. All we know is that it's a potential risk and we need to study it further. We need to study the infrastructure further to see if there's that true risk to that infrastructure. So all of these are risk treatments and risk actions, adaptation actions that are equally valid. And in many cases, we go through the study. So that's really the next steps, is to kind of move forward and understand all of these things. So really, the ideas of what I just spoke to are kind of those next steps. So we really take these further risk actions on those high and medium risks. These help us to take it to whatever next step this assessment has. So I really think in terms of that wheel of where this is done, in terms of that whole holistic risk model, it either informs a planning concept, infrastructure design, a remedial action, a capital program, or something. So we need to see and what that program is, where it is in the phase of your project or your infrastructure, is important to what kind of risk actions you recommend next. In some cases, the risk assessment stops and it becomes a tool to inform design. It's not design criteria in itself, but it can inform how the designer may look to incorporate climate principles into the design, or a design upgrade for new infrastructure or upgrading existing infrastructure. It might literally just inform operation maintenance activities. Like we said, maybe we need to resource more, maybe we need to get new equipment, maybe we need to get rid of equipment and do it in a different fashion. And really ultimately just informs all these areas. And it can also inform an adaptation plan. So many communities might assess their infrastructure, and they may move into adaptation planning very specifically, and this will inform that process. And then once you've gone through this process in terms of assessing, picking some of these adaptation options, we need to communicate it. So it needs to somehow move forward. And once again, that will be based on the objectives. What a usual communication is in assessment is that, the assessment is completed, and then you finalize that with a report. And that report has some components. So if this was done for a climate lens assessment for the government, it would be a report. You would have different recommendations. It would follow a certain format in terms of title, table of contents. It would have attestations and a few things, and that move that forward. In a lot of cases, if we're outside of that, it might just be within the confines of a typical memorandum or technical report that an organization or government would use. You might follow that up with executive summary reports. You might follow that with PowerPoints, presentations as well, and depends on the level of engagement. And ultimately, you have to understand who the voice or the context of the reporting is for. Are you trying to make a financial case? Are you doing cost benefit analysis in terms of things? Or are you looking at maybe even more sustainable decision-making processes like triple bottom line analysis or other frameworks in terms of sustainable design? And within that, as we see the adaptation moving forward, based on the climate, a changing climate and the risks of climate change, changing climate, we see the opportunities for more sustainable solutions, more opportunities to further mitigate in terms of energy reductions, carbon reduction, impacts, and including natural infrastructure and a variety of other principles in your decision making and actions. So I think those are very, very important. I think, just looking at how we used to fix things, we need to revisit, and maybe that's where your end result is, but I think you need to explore more in terms of treatment and how to communicate that as well. And in a lot of cases, community engagement, stakeholder engagement, Indigenous engagement, a variety of things should come into the voice and the communication and how you wrap up these studies. So that moves us to the next exercise. And Sarah, if we want to come back here. Yes. And really what we want to do is we want to go back to those worksheets in terms of those groups again, and hopefully everyone can, if they choose, they can move back into the same groups. And I really want now them to walk through the worksheet as a final step, and we've identified some of those risks in the risk assessment, and just have a little bit of a conversation of what actions could happen in terms of that, management action, no action, remedial action, and a variety. Okay, so we're back. That exercise really, if I look at the previous slide, was really to have a conversation about what kind of risk actions we would take based on anything. That's a little bit of a shorter discussion. In true terms, it's a long discussion and can be a long process as we move through some of these ideas of how we take risk action. But I think in terms of the specifics on each project, I think we just had the beginnings of understanding some directions. And I know that was a fairly short exercise, so not a lot. From our group, I mean, it was probably less collaborative than in the original exercise, but I think really looking at the potential to look at some of the management actions and in terms of remedial action on a highway cross section and maybe improving slopes, water, shedding water farther and away from pavement cross sections and a variety of things in terms of that. And also, well, investigating maybe a little bit more where we saw higher risks in terms of ice jamming and effects on culverts and a variety of things. So those kind of processes moving forward as well. So any comments from your groups, Sarah or Juliana?
Yeah, we had a really good, we had a quick, good discussion, but it was nice because some folks were sort of probing Jessica about what she thought, how she thought this should be used kind of going forward into bridge design. And then we talked about how in the few sort of areas that lit up, what Jessica would do in her experience. So overall good. Yeah,
very good. And Juliana?
Yeah, for our group, we didn't have much discussion, but we had a chat between myself and Karma, is that when we're looking at buildings, for example, extreme winds and tornado and floods, can some of these, especially for high winds and tornado, because it's not a very frequent event, how much remedial action do you actually take on the building? Do you spend a lot of energy on it, and how do you evaluate that? So then we talked about, the value of the building, what does it serve the community, especially like, for example, the historic building has been sitting there for about 150 years. So that's more value to the community than a center, visitor center. So that kind of comes into play in judging what the risk treatment would be.
Yeah, and that sounds like a conversation to maybe drill in and understand your risk tolerance to see whether you're prepared to lose that asset in the future. You might say, okay, we want to protect that piece, so maybe we relocate it higher, maybe we do something different. Whereas other infrastructure that you may be able to do, you can do a little bit different. So I think that's an important concept. Excellent. So I think really. That's what we're having, and maybe the last conversation that we can have before we go into the question and answer, which really is the conclusion of this assessment, because once we get to recommendations, we're kind of done in assessment, is just to as you go through this final process of assessing your risks, to look at your whole risk profile, so your completed risk worksheet, your risk summary. And really take a step back and look at it and say, are there any outliers? Are there any aspects of what I see in terms of the risk that seem elevated or reduced? Do I want to investigate a few others to a higher degree? Or are there a few outliers that just don't seem to fit that concept of a low consequence or a low likelihood, and high consequence means a low risk? And maybe that definition needs to be enacted differently. It's okay to identify some specific items within a risk assessment process and elevate that to a larger degree, even if the risk score is a bit different. So there's still a lot of analysis and thought that goes into that as well. So just one final thing, if anybody is interested in a real deep dive into understanding PIEVC and more PIEVC training, outside of this BRACE program or other BRACE programs, the Climate Risk Institute has training on PIEVC in terms of intensive training processes, and look for that from their system, as well as a process to become an infrastructure resilient professional, and learn more about all of this. So anyway, maybe I'll hand that back to you, Sarah and Juliana, to guide us through any questions and to finalize the session.
We'd like to know what the most interesting concept that you learned about at today's session was.